Well, good afternoon, everyone. I hope you're having a great day, and welcome to this session on introducing the power of scripting in ArcGIS. My name's Laurie Stevens. I'm a GIS consultant here at Esri UK.
My name's Damien. I'm a Senior Managed Services Consultant at Esri UK.
This afternoon's session is going to be split, broadly speaking, into two parts. I'm going to start by introducing you to Arcade, before I'm going to pass to Damien, who's going to provide you with an introduction to the ArcGIS API for Python. We're both going to use demonstrations to highlight some of the capabilities that are available, and we'll finish by providing you with some useful resources to help you get started. So without further ado, let's go straight in and look at Arcade. What is Arcade? Arcade is a lightweight scripting language available across the ArcGIS system that allows you to perform enhanced data configuration, helping you to make your maps and apps as effective as possible. You can author expressions using any accessible data. So this could be data from your own organization, third-party organizations, or the Living Atlas. Expressions are performed client-side, so perform well, and Arcade is pre-packaged with the software, so no additional installation is required. Arcade comes with a compact library of functions to build your scripts from, such as buffer, intersects, and date difference. If, like me, you aren't from a developer background, this means that you aren't starting from scratch. If, however, you're already comfortable with other languages, such as Python and JavaScript, you'll find that Arcade has a familiar structure and logic, such as for loops and if statements, so you'll be able to get off to a flying start. Regardless of your prior experience, Arcade is an accessible tool for enhancing your workflows. You can author Arcade expressions for use in a range of different contexts, the most commonly used being labeling, pop-ups, and visualization. These contexts are called profiles, and there are over 20 Arcade profiles available, all of which are listed in the documentation. You can author Arcade expressions using ArcGIS Pro or the map viewer in ArcGIS Online and ArcGIS Enterprise. You can then view created expressions here, as well as in other ArcGIS applications, such as story maps and mobile applications. This essentially means that once you create Arcade, it becomes accessible everywhere. So we're now going to move into a couple of demonstrations that highlight just some of the ways in which Arcade can be used. Let's start by looking at how Arcade can be used within the visualization profile to configure the way our data is symbolized. On my map, you can see census population summary data for England and Wales. This dataset, which is available via the Living Atlas, combines first release data from the 2021 census with data from the previous 3 censuses. In this example, we'd like to visualize our data according to the percentage change in the population since the previous census in 2011. Now, whilst this information isn't currently directly available within the dataset, we can use the attributes that are available to calculate this information on the fly using Arcade. To do this, in the map viewer in ArcGIS Online, I'm going to come to the Styles panel. And here, I'm going to click to add an expression, which opens up the Arcade expression editor. I'm going to start by giving my expression a name. And now I'm ready to start creating my expression. To do this, I'm going to use something called a profile variable. Profile variables are data values that are used as inputs in an expression. If I open up the Profile Variables tab, you'll see I have access to the Feature Profile variable, which represents a selected feature. This makes it really easy for us to calculate values using a feature's attributes. If I click this arrow here, you'll see that I can view all of the attributes available for that feature, and I can also search through them. I can then click the attributes to automatically insert them into my expression. And I'm going to use this capability to build my expression. I'm going to add some closing brackets. And there we have it. That's my expression there. Once I'm happy, I'm going to click to run. That's going to test my expression, so it's going to check that it's valid, and it's also going to give me an idea of the sort of output I can expect. Once I'm happy, I'm going to click Done. And you'll see that now I've done that, I'm able to configure the symbology of my layer in exactly the same way as if I was using an attribute stored directly within the dataset. We're now visualizing our dataset according to the percentage population change. Just to emphasize, these data values are being calculated on the fly using ArcGIS. Now let's look at how ArcGIS can be used within the pop-up profile. This map contains two datasets from the Living Atlas: UK modern earthquakes from the British Geological Survey, and counties and unitary authority boundaries from the Office for National Statistics. In this example, when a user clicks on a boundary feature, we'd like the pop-up to include the number of earthquakes recorded within that boundary feature. This sort of simple, on-the-fly analysis between two datasets is a great use case for ArcGIS. Bear in mind, however, that there will be an impact on performance as the complexity of your expressions and the size of your data increase. To create this expression, I'm actually going to use a sample expression that I found online in a blog article. There are loads of sample expressions already out there, and from my experience, these are a great way to dip your toes into ArcGIS and see what it can achieve. So to create my expression, I'm going to select my boundaries layer, come to the pop-ups panel, select attribute expressions, and in this case, I'm going to click to edit an expression I started to create earlier. The first step I need to complete is to create a feature set of the earthquakes layer in our dataset. Now, a feature set is a data type that contains multiple features, and we can create this using the feature set by name function available within ArcGIS. Now, I could add this using the Functions tab, but in this case, I'm going to come to Profile Variables, select Map, and you'll see here that all of the layers in my map are listed for me. If I click my earthquakes layer, you'll see here that the feature set by name function is automatically populated with the required parameters for this layer. So as before, I'm going to click to insert it into my expression. I'm then going to equate the output of that function to a new variable that I'm going to create called earthquakes. That's the first step. Next, we need to identify the earthquakes that fall within the selected boundary feature. And we're going to do this using the intersects function. So we're going to open up the Functions tab, and we're going to search for intersects. And I can see my function here. If I click the arrow here, you'll see I'm taken to some documentation for the tool, including background information on the function and the required parameters. I can also click this button here to insert it into my function with some placeholder parameters for me. In this case, the parameters I need to provide are my selected feature, which, as discussed previously, are represented by our feature profile variable, and then the features we want to intersect, which are represented by our earthquakes variable that we created previously. And as before, I'm going to equate the output of that to a new variable called intersect. Now, all that's left for me to do is use the ArcGIS count function to count how many earthquakes are within that intersection. So again, I could add that count function from the Functions tab, but in this case, because I know the function exists, I'm going to start typing. You'll see that the new ArcGIS expression editor comes with code suggestions and code completion. I can hit the tab button to automatically complete my function with the placeholder parameter, and again, as I start typing my parameter, I can hit the tab and it completes for me. Again, we'll test our expression, and once we're done, all that's left for us to do is to add that expression to our pop-up. You'll now see that the number of earthquakes that fall within our selected boundary are displayed within our pop-up. Just to emphasize, as before, this information is all being calculated on the fly at runtime using ArcGIS. So I hope these examples have shown you just some of the ways in which you can use ArcGIS and how easy it can be for you to get up and running. I'd really strongly encourage you to explore how you can use it within your workflows. I'm now going to hand you over to Damien, who's going to introduce you to the ArcGIS API for Python.
Thank you, Laurie. So are you looking for a powerful and modern library for performing GIS visualization, analysis, data management, and system administration tasks in Python? Then look no further than the ArcGIS API for Python. The ArcGIS API for Python is a versatile library that allows you to script and automate tasks with ease. It integrates easily with Python 3 environments and can be used to access and manipulate ArcGIS Online and ArcGIS Enterprise data, services, and web maps. It can also be used for GIS administration, content management, spatial analysis, and data science. It provides a flexible and efficient way to work with spatial data and to leverage the capabilities of the ArcGIS platform. There are other geospatial Python libraries in the ArcGIS platform, for example, ArcPy, which provides geoprocessing scripting capability in a desktop environment, but for the remainder of this section, we'll focus on the ArcGIS API for Python. Okay, so I'm going to show you 3 quick ways, it's going to be very quick now, on how to start notebooks. So if you go log into ArcGIS Online in the usual method, and you go to Notebook, you can click New Notebook, and that will effectively set up a notebook for you. You can also do it in ArcGIS Pro. So within ArcGIS Pro, log in, usual way, go to Insert tab, and click New Notebook. There's a final way to do it, and that is via Jupyter Notebooks. So whenever you install ArcGIS Pro, you'll have the option here for Jupyter Notebook app. You can load it, and effectively it will launch in a browser and give you the same sort of experience as you have in online. Okay, so now I'm going to talk about drumlins and archaeology and all that cool stuff. So in this demo, we'll explore the Irish language's contribution to the field of glaciology and investigate the role of drumlin features in the naming of townlands in Northern Ireland and their relationship with archaeological sites and monuments. So this demo utilises the ArcGIS Online Notebook environment, which is a great way to annotate your code as you go along. So it makes it easier to read and follow. Online notebooks have several advantages over other notebook types. So they make it really easy for multiple users to collaborate on the same notebook through sharing. They offer a secure environment for data processing and analysis within ArcGIS Online. And they're accessible from any web browser, making it easy for users to access their notebooks from anywhere. They offer scalable computing power that allows users to process and analyze large data sets with ease. So the Irish language has contributed to the field of glaciology with several landforms derived from Irish words. Ireland is an easily accessible, recently glaciated landscape, hence a lot of early academic work on glacial landforms was carried out there. The word drumlin is derived from the Gaelic word drumlin, which means little ridge or little hill, and provides the internationally recognised term for these glacial landforms. The townland system is an administrative boundary system of Gaelic origin. Many townlands were anglicised as part of the first Ordnance Survey mapping exercise in Ireland, but most have names of Irish origin and are often derived from prominent local features. So think of Irish townlands as a medieval ArcGIS locator. What I want to investigate in this demo is where townlands in Northern Ireland contain a drumlin, and their names also derive from that word. I also want to investigate if any archaeological sites or monuments are located within these townlands. So first things first, we need to import the GIS module. Anyone who's worked with notebooks in an online notebook environment, you actually only have to reference the home variable. You don't have to provide login credentials like you usually would. So, the data. I've gathered data from 3 open data sets: the Townlands boundary layer for Northern Ireland, the Northern Ireland Sites and Monuments record, and drumlins for the island of Ireland from the Living Atlas. I've also created 2 feature layer views that I'll describe later. So let's add the data and 2 feature layer views to this notebook. Okay, so first things first, we're going to create a map centered on Northern Ireland, setting the base map as dark grey. So using feature layer views, I've created a subset of townlands data to filter whether their names are a derivative of drum, or drim in English, which suggests the likelihood of the presence of a ridge or hill feature within the townland. All townlands that meet this criteria were attributed with a value of 1 against a new field called drum_deriv. You can see there's quite a few there. Next up is the drumlins layer. So what I've done is I've clipped that layer just for Northern Ireland to reduce the amount of data being pulled through. And we can see there are areas where there is a relationship. Okay, so I performed a join between the townlands layer and the drumlands layer, and attributed with a new field called drumland_present with a value of 1. This gives us the townlands that contain a drumland, so I've added this to the second feature layer view. You can see there are plenty of townlands that contain drumlands, but their name has absolutely nothing to do with drumlands. So we'll just focus on those that do. Okay, so let's show the joined townlands layer, where the townland is derived from the word drumland and it contains a drumland feature. So we do this by applying a filter where drum deriv equals 1 and drum present equals 1. In these instances, there is likely a relationship between the name of the townland and the drumland feature. And finally, for the final data set, I've joined the sites and monuments records for Northern Ireland with the joined townlands layer. It's been filtered to only show sites and monuments that are contained within townlands that have a drumland, and the townland name is a derivative of drumland. So you can see there's a substantial cluster here of archaeological sites around North County Fermanagh. So let's take a look at a dashboard that breaks down these sites and monuments. So we can see here that the vast majority of the sites that have drumlands present are from the early Christian period in Ireland. This is the years 400 to 1000 AD. There's a real acceleration of structures during this period, which indicates that drumlands were becoming increasingly important during this time. Many of the structures that have been identified on drumlands are ring forts, which were used primarily as farm enclosures, defensive structures, and a bit of a flex of authority in a petty kingdom. So after the Viking and Norman invasions of Ireland, the role of ring fort structures was abandoned in favour of larger, more defensive structures. And this coincided with the same time when the petty kingdoms formed to form the 4 provinces of Ireland. So given the prominence of drumlands in the naming of townlands and the wealth of historical, cultural and archaeological evidence produced from them, these landforms hold a special place in Ireland's landscape and history. So this is a very simple demo just to show you how exploring relationships between data has never been easier with the ArcGIS API for Python and ArcGIS online notebooks. There's a whole host of additional capabilities that the ArcGIS API for Python offers. So we can do organization administration, deep learning, content publishing, data science, and so much more. I'm just going to now walk you through some of the key resources. So this is the landing page for the ArcGIS API for Python. You can see the current version was released on March 6th, 2023. If you go down the left-hand side here, or yeah, it's left there. So key features, get started, installation setup, tutorials, release notes, and then we've got some of the key capabilities here as well are highlighted. We can also have our system requirements, for example. Another thing worth noting is the sample notebooks. So we have lots of really good sample notebooks online. So from your very first notebook to quite complicated notebooks that developers and power users can use. We also then have notebooks for managing your organization, for organization administrators. So that's the batch creation of groups, content, portal users, etc. We then have a whole host of GIS analysis and data science notebooks that are available online. And we also then obviously cover deep learning, 2D, 3D computer vision tasks, and then we can also do lots of content publishing notebooks here as well. So that's just a quick run through. I've shown you a few ways that you can get started with notebooks, a quick simple demo that shows some of the visualization and storytelling you can do with a notebook, and also then some of the key documentation. I'll now hand back to Laurie.
Thank you, Damien. So we just wanted to finish by providing you with some really useful resources to get started. Those 2 resources that Damien just discussed for the ArcGIS API for Python, you can see you can access via the QR codes on the right-hand side of the screen. I've also provided you with 4 QR codes for Arcade. There's a learning path that I'd really recommend if you want to get started, really useful for getting hands-on and just trying your first expressions. I've given you a link to the Arcade documentation. That's where you'll find kind of information about functions, those profiles that we discussed previously. There's a QR code to Arcade blogs that have been published by Esri UK. They give some really useful ideas on the way in which you can use Arcade, and that's where you can find some really nice sample expressions, like I showed. And finally, there's a link to the Esri GitHub page, which contains loads of sample Arcade expressions for each of the profiles. And so those can be a really useful way to just copy and paste those, change it with your own data and values, and see what you can achieve. So I hope this session has been really useful. I hope it really encourages you to see how, just a simple script can really enhance your workflows. Thank you all for your time. Enjoy the rest of your day. And if you have any questions, feel free to come up to us at the end. Thank you very much.